Hello, in this video we're going to take apart an object in order to find forces that are acting internal to the object. So in the example we have drawn here, maybe I have some kind of metal bracket that has a bend in it, and I want to find the forces at point A. So what we're going to do is take apart this bracket into two objects. We're going to think of the bracket as made up of two brackets welded together at point A. So if I do that, I've got the bracket on the left. No, that's the right. I've got the bracket on the left and the bracket on the right side, and I've separated it at point A. Now the actual bracket would be these two parts welded together at point A. And I've also indicated on each of these two sides what all the forces acting on that object would be. I'd still have the 10 Newton force. I just also have a connection where the two halves would actually be put together. And they'd be put together in a fixed connection. So I'd have a force in the x direction, a force in the y direction. So there's a y, an x, and also an unknown moment, ma. And acting on the left side, I'd have equal and opposite mirrors of those forces. So I'd have an ax and ay, but the ax would be to the left and the ay would be down, and I'd have a moment in the other direction. We can then solve for these forces. Maybe we'll do some of the moments around point A on the right beam, in which case we'd have the 10 Newton force times, and if I assume each of these tick marks is exactly 1 meter, we'd have 10 times 3, and that's going to be in the positive k-hat direction, plus the moment around point A due to ax, which is 0, the moment around point A due to ay, which is 0, plus the moment ma. And all that adds up to 0, so that moment ma would and we can then find ax and ay by balancing forces. So we'd conclude that ax has to be negative 10 newtons to balance out the 10 newtons pulling to the right on the right beam. And ay would have to be 0 because there's no other forces in the vertical direction. Okay, we now have solved for the three components of the reaction at point A. I would have gotten the same answer if I'd worked on the left side of the beam instead of the right side of the beam. Okay.